This is question 5b. In part B, we're asked how many years at the same rate of interest would it take to double the investment? So we're going to continue using the same recurrence relation. The investment initially, U0, was £300. So what we want to know is how many years does it take until we have over double this amount? In other words, how many years does it take for the investment to grow to more than £600? So there's a couple of ways to do this. If we think back to part A, we worked out U1, the investment value after 1 year, U2, U3, U4 and U5. We can continue on in this vein. So what we have here on screen is the tail end of part A. U5, the investment value after 5 years was 1.045 multiplied by the previous year's total, so that was U4. That gave us the total value of the investment after 5 years. What we can do now is just keep going. We can work out U6, find out what the new total is, then go on to U7, U8, and so on until we get a number that gives us more than 600. So if we apply the same strategy, first of all, U6, that equals 390.6780. So we need to keep going. U7 is 408.2585. U8 is 426.6302. It's 445.8285. So if we keep repeating this process, our investment amount keeps on increasing. When we get to U15, we have 580.5847. So we're getting quite close to doubling our investment now. U16, carrying out the same recurrence relation once again. That gives us 606.7110. So the question was asking how long to double the investment. So our initial investment was 300. We have now gone beyond 600, which is double that amount. Each number, each recurrence relation represents a period of 1 year. So this was 5 years, 6 years, 7 years, 8 years, and so on. So the answer to the question is of how many years at the same interest rate would it take to double the investment? Well, it has taken 16 years to double the investment. There is an alternate, quicker method to do this question, which saves all the extra working. If you remember back to credit, when we were looking at compound interest and so on, we looked at a quick method of doing these questions. So we'll have a look at that just now. Because this particular recurrence relation has no number being added on or subtracted at the end, then what we can do is we can take the initial amount, 300, and we're going to multiply that by, and our multiplier was 1.045. So essentially all we're doing is finding an answer to this and repeating the multiplication and then repeating it again and so on as each year goes by. So what we could do is use our calculator at this point and try some different numbers in here. If we put this at 1.045 to a power, so for example, if we do 300 times 1.045, and that's to the power 6. Then we get 390.678. And if we look back at our previous question, that was the value of the investment after 6 years. So that number obviously isn't double the initial investment. So what we need to do is try a higher number in here. So what we can do is, through trial and error, try some different numbers up here, and hopefully through a process of trial and error, that would lead us to trying 300 multiplied by 1.045 to the power of 16, and that would give us an answer of 606.7110. So obviously, if you try a power up here, if it gives you more than 600, you can't just automatically assume that that one's the right answer. So if through sheer luck we had tried 16 to begin with and it gave us an answer bigger than 600, what we need to do is then try 15 in here and just check that that is not also higher than 600. So if you were to try 15 in here now, you would find out the answer is in fact less than 600. So we know that this is the first time where the investment goes above £600. So that means the length of time taken to double the investment, or more than double the investment, is 16 years.